Okay, so one thing I want to show you is how to calculate velocity and acceleration. Your basic equation for velocity is velocity equals distance divided by time. Your basic equation for acceleration is going to be your final velocity minus your initial velocity divided by time. So acceleration is change in velocity over time, speeding up or slowing down. Okay. Now your units, okay, for velocity is going to be meters per second. Okay, a distance divided by time, meters per second. Acceleration, of course, velocity is meters per second divided by seconds, and sometimes that is written meters. Okay, I don't know why my pen is not working right now. Meter, hold on. Meters per second squared. Okay. Now, one thing to keep in mind, both of these, velocity or acceleration, can be negative. Negative just means you're moving left, down, backwards. Okay, a positive number just means you're moving up or to the right, or sometimes forward. So don't be surprised if you get negative answers on any on some of the problems on the worksheet or for practice. These equations will be given, so you don't need to worry about memorizing any equations, just have to know how to do it. But part of our quiz will be doing these two calculations, calculating the velocity of an object and calculating the acceleration of an object. So let's take a second here and do maybe a couple of sample problems. Okay, so let's try a sample problem here. Look at number 3 here. Light from the sun reaches the earth in 8.3 minutes. The velocity of light is 3.00 times 10 to the 8th meters per second. How far from the earth is the sun? So in physics, we always want to list what information we know. We know our time is 8.3 minutes. It gives us a velocity of 3.0 times 10 to the 8th meters per second. And I want to see if I can change the color. I don't know how to do that on my ink pen here. All right, hold on, I'm going to pause and see if I can figure that out. Okay, so I think I figured it out. Let's see what happens. It looks a little darker, so that's good. So we know velocity is distance divided by time. And what are we trying to solve for? How far? So I'm looking for distance. Trying to solve for the distance. So I know the velocity, I know the time, but in physics class we got to pay attention to our units. And I notice I have minutes and seconds here. So over here off to the side, I'm going to do a quick little calculation because 8.3 minutes, 1 minute is 60 seconds. Okay. So if I take 8.3 times 60, as I try to pause because I forgot to have my calculator ready, I get 498 seconds. So now that my units match, I am able to do my calculation. So 3.00 times 10 to the 8th meters per second equals d, which I don't know, over 498. Okay. So to solve this, I would take 3 times 10 to the 8th times 498. I get 1.49 times 10 to the 11th, and always in physics you want to have a unit. In this case it is meters. So the sun is about 1.49 times 10 to the 11th meters away, or 93 million miles. So let's look at number 7 here. When a bus comes to a sudden stop to avoid hitting a dog, it slows from 9 meters per second to 0 meters per second in 1.5 seconds. Find the average acceleration of the bus. So again, list what you know. Slows from 9 to 0 meters per second. So I know my starting velocity, we call it the initial velocity, is 9 meters per second. We know the final velocity is 0 meters per second. We know time is 1.5 seconds. Of course, we're trying to find acceleration. So acceleration is Vf minus Vi divided by t, the time. So it's 0 minus 9 divided by 1.5. So that means negative 9 divided by 1.5. And I'm trying to make sure I have enough room here, but negative 9 divided by 1.5 is 6. So it's negative 6 meters per second squared. Notice your units. Notice it can be negative, which basically means you're slowing down relative to your motion.